Hello, today I want to talk to you about graphing absolute value equations with two variables. And if you recall graphing parabolas, this will be very similar. Okay? So the first thing we should look at is graph y equals the absolute value of x. Okay? And let's compare it to the graph of y equals x. So the graph of y equals x at this point should be very familiar. Just diagonal line. It goes from negatives, like -3, -3, to positives, where the value of each part of the coordinate is the same. Okay. And that makes sense. What this says is the y part of the coordinate has to be the same as the x part of the coordinate. So if the y is -3, if the y is -3, the x is -3. If the y is 3, the x is +3, so on and so forth. Now, this equation is very similar, except what's going to happen when x is a negative. For example, when x is -3, what will y become? Y will become +3. So that, up here. Okay, and on the positive side, nothing should change, right? Because +3 will stay +3, still be +3 for y. So all of the points on the line from here to positive infinity would be the same. It's simply the points in the negatives that will be, we say, reflected over the x-axis here. And so what you get instead of a line is kind of a V shape, and it will open up. Okay, so this is the equation y equals the absolute value of x. All right. Now, just like we had with parabolas, it is possible to shift this equation around and to compress it and stretch it. And the way we do that is almost identical. So let's take a look at that. If we wanted to shift the graph one place to the right, we would do the same thing we did with the parabolas. Just put a -1 here. And now if people were confused why the -1 is going to shift things to the right rather than to the left, I still think the clearest way to think about that is to make a table of values and note that the value, you're shifting the position of the y's and the x by 1, but if you don't want to do that, you can just remember that it goes the opposite of the way you might think. Inside here, if you subtract 1, the graph is going to go to the right. So this will result in a graph that looks like that. All right? And it's that 1 that shifted it 1 unit to the right. Now, if we wanted to shift it up and down, again, it's the same as with the parabola. This value just needs to be outside of the absolute value portion of the equation, and that will shift it up. And in this case, positives make it go up, and negatives make it go down. So this will result in a graph like so. Okay. Now, if we want to compress or stretch the graph, we use a coefficient in front of the absolute value, like this. And that is going to double, just like it would be if it was y equals 2x. Here it's going to be just a line that's twice as steep, and it's going to be reflected again because all the negatives will become positive, but it'll just be reflected at that same doubled steepness, and it'll look just like that. So instead of going through the point 1, 1, it's going to go through the point 1, 2. So you can think of it like a slope of 2 from the start of your vertex, it goes up 2 over 1. If we want to make the graph open downwards, we simply use a negative, and that negative needs to be in front of the absolute value, because if it was inside it, it just wouldn't change anything because they'd all still become positive values. But this will result in a graph like this. And the reason for that, I hope it's straightforward, is because the graph of y equals -x would just be this. but all values, no matter what you put in here, are going to be positive, and then they're going to all become negative. So you can only get negative y values out of this function, so it can never be positive. So it's just going to bounce here, the opposite direction. So like I say, it's very similar to parabolas. I'll just do one example, sort of adding that all together here. So I'm going to start by finding where my vertex, that's the bottom or the top of the V, is. And that's going to be at positive 2 on the y-axis and negative 1, because remember, positives make us go to the left here. So it's going to be right there. And now my compression factor, if you want to think of it, or stretch factor, whatever, is 3, and it's negative, so it's going to open down, and it's going to go down 3 for every 1 that goes over. Okay, so it should go through those 2 points, or something close to that. Okay, so just running through that one more time. First I found the point of the vertex, and that was by going up or down this many places, and left or right this many places. And then I looked at the stretch and the direction. The direction is determined by whether this is positive or negative, and the stretch is just determined by that number. So this was like a small fraction. It would be a very wide sort of V. And if this is a large number, it'll become very, very narrow. Okay. I hope that is relatively clear. I think most of the equations I give you will be solved for y, so they'll already be in that form. But if for some reason they weren't in that form, you just have to put them in that form in order to graph